Hi guys, let's look at this math practice problem, the one about how many acres it takes to support this owl. So it says you visit a nearby barn and discover it has a barn owl living in it. The owl is full grown with a mass of 2 kilograms, lives entirely on small animals like meadow voles, feeds on grain stored in the barn. Owls generally consume about 250 small animals per year per kilogram of body size. Each vole has a mass of about 50 grams, and they consume 60% of their body weight in grain per day. And then we're going to do this for Indiana since that's where he discovered it. So the average wheat yield per acre is 60 bushels, same as 1,620 kilograms. So our question is how many acres of grain are required to feed this owl each year? And I'm going to not do the math on here with actual the multiplication and division and all that stuff, so you can just do that off to the side. So just pause the video, do all that stuff, and then continue on. So this is really just to practice the setup of the problem. Okay, so just like always, 2 important things. Okay, what do we know and where do we need to go? So let's say, start with what we're trying to figure out. Okay, in this case, here's our question. It says how many acres of grain are required to feed this owl each year. So we know our answer is going to be in acres per year. Okay, and we need to figure out a starting point. Okay, that's our what do we know. Okay, so we can really start anywhere, but let's look at the big picture first. Okay, think about when you see a problem like this, what are you actually trying to figure out? Okay, and in this case, we're tracing backwards. Okay, we want to know how many acres it takes to support the bottom of a pyramid, so that we can work our way all the way up to the owl at the top. Okay, so if you remember from chapter 3, we looked at these energy pyramids and biomass pyramids. Okay, what we're really trying to figure out is if we have an owl here at top, how much stuff does it need to eat and how much stuff does that need to eat? Okay, my arrows, I guess technically are backwards since we're looking at energy flow. And what we need to know once we know how much stuff we have down here is how much land it takes to grow it. Okay, so let's start on with our next page here. The problem is still up there at the top, just a little bit smaller. So in this case, again, we are trying to get to acres per year. Okay, I'll write that back down here, acres per year. Okay, and we have quite a few steps to get there this time, but most of the stuff is just going to cancel out, so the math shouldn't be too difficult at the end. So start with what we know. So we know that 1 owl is 2 kilograms. So 2 kilograms is the equivalent of 1 owl. Okay, and remember, just like I always do, we're just trying to cancel everything out. So just keep reading and see what we can cancel. The next sentence says that owls generally consume about 250 small animals per year per kilogram. So there's our kilogram again, so that I know for every 1 kilogram of owl, we need 250 animals. Okay, so we've canceled kilograms. We still have animals and owls left. Okay, we're not going to cancel out our owls right now because we need those at the end, acres per year per owl. So let's continue on with trying to cancel out the animals. The next thing says that voles have a mass of about 50 grams. So we know that 1 animal is equivalent to 50 grams. Okay, and then let's keep reading. They consume about 60% of their body weight each day. So we can go ahead and stop and put that in here now, just because it's the next in order. Remember, all of this stuff can go anywhere as long as everything eventually cancels out. So in this one, let's do 60% of its body weight every day. So we haven't canceled anything yet. We've actually added in a new thing. Oh, we did cancel animals. We haven't canceled the grams yet. Okay, so we're still going to just keep that in mind. But again, the order doesn't matter as long as it eventually cancels out. Okay, if I still keep reading, one thing I could do right now is go ahead and get rid of the grams by converting it to kilograms, since the rest of our problem is in kilograms anyway. So we'll probably need to do that at some point. I'm going to do it now. Doesn't matter when. Okay, so I'm starting here on the second row. 1 kilogram is equal to 1,000 grams. Remember, grams goes on the bottom because it was on the top there before. Okay, so we're done with that. And now what we have left is, let's see, kilograms per day. And we're going to keep going then because we're trying to get to acres per year. So work on either one, doesn't matter which one. I might go ahead and do the days right now. Okay, doesn't really matter. I know I can cancel days and get it into years. That's a 6. Days in 1 year. Okay, so my days are gone, and now I'm in kilograms per year, so I'm just going to keep reading until I can cancel something else out. And then it says, let's see, in Indiana, the average wheat yield per acre is 1,620 kilograms. So there's my last kilograms. 1,620 kilograms, 1 acre. Okay, cancel that, and let's look and see what we have left. Okay, we still have our owl left, which is good because we want to know acres per year per owl, which I can't fit in that space. And then if we keep looking, we have years here on the bottom and acres here on the top, and that's exactly what we need. Okay, so really we're done. I'm going to plug all this stuff into the calculator to make it faster. You guys are going to do it all on paper. Remember to use scientific notation anytime you can. And you know, the zeros kind of cancel each other out, so you could do that ahead of time and cancel some of those zeros to make it a little bit less math for you. And if we keep going, you know, multiply all the numbers across the top right here, and then all the numbers across the bottom, okay, and then divide, I'm going to end up with 3.38 acres per year.